first impression looking at this first slide, for the professors here, it's probably going to be very, very simple, investigating binding affinities via molecular docking. I'm guessing for many students here, it might seem like a very complex topic, but for our presentation, we're going to, keep things very simple and instead focus more on the journey that of our research and lessons that came about through that, as well as why we think STL could be an amazing opportunity and maybe even some tips for how you could also get an award. So really quickly on both of us. So I'm Cyrus, and
Yeah,
speaking with you is
I'm Dorottya.
Yep. And as Professor Wang said before, we won the silver award in STL Asia and the bronze award in Beijing. So, first of all, just want to talk a little bit about our inspiration. So, actually, it wasn't anything surprising, it wasn't anything technical. We didn't look deep into like some papers online or anything. It was really just, when walking around Hong Kong, we saw a bunch of ads by Gung To, which I'm sure many of us here know. And he for a time he was doing a lot of ads relating to HPV vaccines. So we kind of thought, okay, there's a lot of HPV vaccines, which is good, but how about for the people who don't want to take vaccines or can't take vaccines for one reason or another? Is there some sort of cure for them? And we discovered that actually it wasn't really an effective cure at the time. And so we dug a little deeper and we actually landed on the, I would say, overarching topic for our research, which is drug repurposing. So just to keep this simple, as you see from this flow chart here, this is actually an excerpt from our presentation. The traditional drug discovery process takes an extremely long time. And if you instead use drugs that already exist and instead repurpose it, you can reduce that time by a lot, reduce the risk and reduce the cost because we already understand the side effects very well. So I'm gonna give it to Dorica and she's gonna explain. Oh, actually, before that, sorry, I just want to actually one of the first lessons we learned here is that science allows us to turn inspiration into impact, right? Because our inspiration wasn't anything incredibly complex. All we did was we saw a problem in real life and we thought, how can we solve that with science? And yeah, I think science really has the power to do that, even though right now, in many schools, if in the typical curriculum, we don't really learn problem solving. But I think if we look around the world a little bit and look at problems that exist, we can realize that science can tackle a lot of these problems, as Professor Shem also mentioned before.
Yeah, so the first thing that we had to learn and to tackle when we started researching was understanding and learning how to find this higher level research. We knew that the topic that we wanted to explore and the topic many of you guys, if you choose to participate, are going to explore much beyond the scope of what high school teaches you. So just looking at the two diagrams, which are ones that we used and look towards consistently during our research, it's very complex. And if it does touch on something that we did in high school, it went far beyond what we had actually learned. And also, we didn't have a teacher to hand select the things that we were learning. We didn't have someone to teach it to us. We had to search for this independently and lead it with our own discipline as we were constantly trying to understand these research papers that had terminology we hadn't learned before and so on and so forth. And this obviously proved to be very challenging, especially because as students, we had a lot of other things going on and a lot of content that we were learning. So to add on this new content was a big challenge, but throughout the process, we were able to find a lot of satisfaction through the challenge. And that was kind of our first lesson. So by doing more and more research and interacting more and more with the scientific aspect of our topic, we were able to understand our topic better, and we became prouder and prouder of what we were achieving. Because we saw that we were overcoming these challenges and not understanding the terminology or how the method works. And so we were able to use this as kind of a milestone in our scientific journey. And so the fact that even though it was challenging, even though it was hard, that was kind of what made it so impactful for us and such an enjoyable experience. And then after we've started to understand what we were learning about, we had to develop our research. We had to develop how we were going to draw any conclusions from this. And so sorry that we don't have any interesting pictures on here. Most of what we did was on the computer and through coding. So that is all we can really show for methodology. But what we submitted initially was very different from what we ended up doing. Initially, we wanted to use GROMACS, which was a completely different software to Autodoc Mina, which is what we ended up submitting. But the reason we had to stop using GROMACS was because we found that it was beyond our capabilities, and we were not able to actually conduct the research that we wanted to using GROMACS. And we needed to actually switch gears and try something new. And you can imagine how disheartening this was and how difficult this was to realize, especially because there was a lot of pressure with deadlines and wanting to do something good. But because we were able to work as a team and brainstorm something new, we were able to persevere and learn the second lesson that adaptation is incredibly important in the research process. Because if you adapt, then you can find a new way to solve the same to arrive at the same kind of end goal that you wanted initially. So we've learned that even though setbacks are inevitable, if you rethink things and you're able to shift your perspective, you can still accomplish the goal that you wanted in the first place. And we were able to do that very successfully by running code on Autodoc Vina instead of GROMACS.
Sorry, just to make our research very simple to everybody first before I explain this next part. Essentially, as we said before, drug repurposing, we're trying to find drugs that can treat HPV, and we ended up investigating a group of compounds called quinolins that may be able to do this, and that's why Dorottya talked about that molecular docking, where we tested the binding affinities of the quinolins, essentially telling us how effective they are. But actually, a big part of our research involved the use of AI, right? And I think that's actually quite like an edge that us students may have when it comes to science, because I think we're more wary of new things that emerge, for example, like AI that could be applied to science. So just to give a very brief introduction to the way we use AI in our research. So essentially, our process is three steps. First, we would go on this software called elicit.org, which essentially helps us find research papers. And then once we find those research papers, we use it to train an AI, which we use Poe. And finally, this AI could help us narrow down the key papers that we should look at and key excerpts, which significantly increased the efficiency and lower the time spent on research. Because oftentimes with these very complex topics, especially as students, where this is not covered in the curriculum, it's going to be hard just looking through all those papers and trying to find the right thing. So AI can help, bridge that gap significantly. So we thought that was extremely useful. And in addition, we want to talk a little bit about our novel methodology for our research, where we actually combined several subjects. So even though we won the chemistry award, it actually involved use of biology, because as Dorica said before, we had to identify those binding sites, and that required knowledge of biology. Exactly how does HPV work? How does it cause cancer? That's the biological aspect. And of course, there's a chemistry aspect. And specifically here, the interesting methodology that we developed was relating to benchmark drugs. So, the question is, how do we know if a binding affinity is high or low enough in order to treat HPV? And the way we found this out was by finding a benchmark drug. In this case, we found a drug called nalfinavir that we know is effective in treating HPV. And by placing binding affinity of these candidate drugs to this benchmark drug, we then know exactly how effective it is. So that required a lot of knowledge of chemistry and finding the exact compounds which can be repurposed. That was also a lot of chemistry as well. But also, I think mathematics is integral to essentially all of STEM. And in this case, our use of mathematics was called Z-score benchmark focused Z-score analysis, where essentially we would place all of these compounds on a Z-score scale, and Z-score essentially how far away from the mean a certain number is through standard deviations. And we basically did that for all of our candidate drugs relative to the benchmark drug. If you want to know more, I think we have a paper online, but that's the general synthesis of what it is. And the point I'm getting at here is that there's an opportunity for innovation here for science, especially for young students, because as I said before, something like AI, developing these novel methodologies, I think it requires some creativity. And I think as students, we're young, we know a lot about the new things in the world, and I think by combining these things together, we can make some meaningful innovation.
The last thing we want to talk about is what it was actually like to participate in the competition and what this competition specifically gave us by doing this research. So, as a result of reaching the finals, we had to develop an oral defense, which was a skill that we've never really had to do before. And that was just explaining our research and also answering questions that these very important members of the scientific community, specifically in the field of chemistry, would have to ask us. We were presenting in front of professors and people who have made great contributions to the field. So it was quite intimidating. But thanks to the help of our supporting teacher, we were able to create a defense that express ourselves very clearly. And we were able to get a lot of questions that made us think about what we were about our research even further and even helped us develop our skills in chemistry a little bit. And then, as a result of winning silver, we got to go to Beijing, and that's why you're seeing this picture on the slide right now. In Beijing, we got to participate in a lot of activities that better immersed us in the scientific community. And one of those was attending several science talks by many famous scientists. And one of them included a special screening of The Man from Nine Dimensions, a movie that Hiroshi Oguri made that we also got to listen to talk. And we also got to receive books on new scientific theories and so on. And we got to interact with a lot of like-minded peers who were also in the midst of their own research and doing their own different kinds of novel novel research. And so being able to interact with the scientific community in this way through this competition was something that was really gratifying and something that we're very grateful for the opportunity to have had.
Yep. And yeah, just to conclude, so I think just final thing I want to say to all the students here is, you know, this competition, or even if you don't join this competition, I think it's really important that we step outside our current high school curricula, because as I said before, we need to, there's problems out there for us to solve that science can be a tool for. And I think a really good quote that encompasses the reason as to why we should pursue science and beyond is the more you know that you don't know. Yeah, and this was clearly seen during, for example, our oral defense, right? Actually, Professor Wong, who is in this call, was actually the judge for oral defense, and he has so many tough questions that makes you realize, wow, there's actually a lot that we don't know. And I think, you know, whether you're a person who wants to solve problems in the world, or you're just a person who's really interested, wants to go deep on a subject, learn more about it, I think science is there for you, because science can be used to solve a variety of problems. And science is also perhaps one of the things where you can keep discovering more and more, but you can never discover everything. And I think that's the beauty of it. So, and last words on STL competition. I think it's fantastic competition because you get to create your own research report from start to finish, right? It's not like traditional Olympiads where, you study a subject and do a test. No, you have to truly innovate, do something that's outside of the scope of your high school curricula. And I think that's extremely valuable. So yeah, I hope that was helpful, and good luck on your scientific journey.